Good afternoon, everyone, and welcome to the Network Management Research Group session. So I'm Jérôme François, I'm co-chair of NMRG, and with me today also the other co-chair, Laurent Siervaglia. So before we go into the session, let me remind you um, a bit the different notch wells. So the first one is regarding intellectual property. So because as at NMRG, as IETF, we also follow the IETF intellectual property right disclosure rules. So in particular, you have to disclose some information related to intellectual property in a timely manner regarding patents and also. So of course, here you have the different reference documents that you can also look at. So please read the text here and refer to the document mentioned in case this applies. Also, as you know, so the session is recorded, audio and video. So it's important that you are aware of that. So in case, of course, if you do not want to be recorded, we just remind you here that you have to have this specific red lanyard. Otherwise, you consent to appear in a different recording. And of course, um, if you're online and you speak to the microphone and you use a camera, although it means that you also consent to be recorded. So otherwise, you do not consent, and if you are for people online, you must not switch on your microphone or your camera. So regarding now the privacy and code of conduct, of course, again, we just remind here again that there is some recording, but also that we have, as a group behavior, we have to respect each other during the presentation and discussion. And of course, in case you need more a document about that, you also refer here to the document, to the different documents, so you may consult. In case, for example, if you want more information about how we can manage a different behavior if there is issue. So now important things we want to remind, so it's NMRG, so it's RG, so research group, so part of the IETF. So we are not, main aim is not to develop standard. So as just as a reminder here, the role of IETF is to focus on longer-term research issue related to the internet, while the parallel organizations, the IETF, focuses on short-term issue of engineering and standards making. So it means that even if we can publish RFC, in particular informational RFC, it's not the main aim of the group. And of course, again, you can consult here the RFC 7418 for more information about that. So here's some useful links. So of course, we will be also, we will also notes that will be taken. So of course, if we are too, so we are also taking note. But if you want to help on that, please also feel free to connect to the notes to help us to get all the notes. And video will be available about after meetings on IETF YouTube channel. So regarding this week, we'll have two NMRG sessions. So one today now, and the second one on Thursday. Just maybe to just, of course, you'll see the agenda of the today's session just after this slide, but for Thursday meeting, just maybe to recall you, one part of the meeting will be dedicated to discuss more about the research agenda of the group. And particularly, you may have seen on mailing lists that we were circulating a survey about the positioning or possible positioning of the group regarding, let's say, green networking or sustainable networking. So if you want to provide feedback, it's still open. So of course, we will collect all answer, I would say maybe 1 day or 2 days before the meeting. So just not wait too much before answering the survey, and we'd be more than happy to have more answer to help us proposing a positioning of a possible positioning of the group regarding this topic. So regarding today's agenda, after this short introduction, we have 4 talks that I just giving here. Sorry. So with the first one focused on network digital twin, then one about knowledge graph for young-based network management, and one about the related to the AI topic, so consortium of network system for AI services. So also just to complete this short introduction, you may have attended the IETF open meeting before, so we just recall that there were a presentation of the Applied Networking Research Prize. We just here recall the different presentations that you may have seen or not, but it's just to also highlight you that if you are interested also to meet the different authors, it can be a good opportunity to meet them as they are around this week. And also another announcement for part of the IETF activities. This is the NRW, which is Applied Network Research Workshop. That will be tomorrow. And again, I think for in part of the IETF and research group, it will be also a good opportunity to do some applied research with different papers and also keynotes. I think the program is very rich, so you can check the program here, and of course attend the workshop. You want to add something?
Yeah, I mean, also important for people in the room, please connect to the Meet Echo via the QR code or directly on the web. That's very important also to register your participation to the session. Thank you.
Okay, and that's all for this introduction. So I think we can start with the first talk. So first talk is by Marco. Ah, okay.
How can I progress? Or you do?
Should have this.
Ah,
okay. Should put on mine or should here?
Well, it's close enough. We can also.
Just let me check this. Even work on mine.
Installation. Let me start talking already. So
just let me know when you want to change slide.
Okay, that's the easiest one. All right, my name is Marco Liebsch from NEC Labs. This material is joint work with Martin and Neil from University of Applied Sciences Darmstadt in Germany. And next one. So we actually started looking into some spending thoughts on the complexity and challenges associated with designing, building, and operating network digital twins. So we started looking into, well, on the right side, the sensor networks in smart city deployments. Then recently we moved to wireless networks, how to model wireless networks, how to predict impact of certain aspects in wireless networks. Now we start looking into transport networks and mobile core networks, which is a bit of more an overlay, right? So the draft as we published exists in its initial version 0.0, and it starts discussing practical aspects and challenges when designing and operating network twins. Martin and his team at the University of Applied Sciences in Darmstadt, they started to get experience from some hands-on experience by building an SDN-based network digital twin, which we started to report about in this draft too. So it's a little bit of complementing the already adopted work in the NMRG group about use cases and architecture for network twins. Next one, please. All right. Without listing or describing all the content of the draft, so if you're interested, please have a look and give us feedback. So we start with some assumptions and claiming challenges. So of course, the network twin needs to be aware of the network that it has to build and represent a digital copy from, about its level of abstractions, and of course about the data points to collect from the network nodes, network functions that are associated with that network. At least one model needs to be applied to perform emulations. It receives probe requests from users that want to see how a particular network change has impact on the network operation, as one example. That should be separated from enforcing these changes in the physical network. Well, physical network may not be the right term because it may be a virtual network too, but the operational network or the active network, the real network, whatever. So that should be separated. The probes from a user can be either intent, or the user may also have the skills and capability to ask for particular changes in selected attributes. So he may not need to have an intent, but have the control on the network and knows what he does. Scale and accuracy. So, well, compared to a twin of a robot or a twin of a set of sensors is different from a twin of a network. The network can be arbitrarily large. So the larger the network is, the more components it comprises, the higher the volume of the data points to collect and take into account gets. So the nodes to monitor are diverse too, right? You have switches, you have routers, whatever you want to consider in the twin. So that really depends on the use case and what the twin is to be used for. Accuracy, the more accurate you want to model a network, the more data points you need to collect. So scalability and accuracy are two important factors to decide before you design and build a network twin. Also, the users of a network twin may be very diverse and have different expectations on what the twin should do for it. They may have different views on the network abstraction levels. And parallelism may also be a problem if you have more than one user of a twin. So if they try to model or even enforce a particular change to the network in parallel, there may be a conflict or an interference. So that's aspects, some of them, we describe in the draft that are to be considered. We sketched a few functional elements to have a discussion on these challenges, which we show in the subsequent slides. And then the part on the hands-on experience with a software-defined network digital twin is also described in the draft. There is more, which can be added later on, also in terms of further evolution of the testbed. Next one. So just as an example, we sketched a network twin, which we intentionally separated from a network controller here. So the twin should have an OEM kind of system on top of it and an interface to it. For example, to initialize or change the network twin in its behavior. For example, about the network that is to be monitored and to represent and build a twin model for. In terms of scale, in particular for large networks, we thought about distributed deployment of network twins and model federation. So to a large extent, we even thought about in-network computing to build a twin only of one particular node or of that node with a few neighbors, which keeps also the collection of data points, the latency in transmitting the data points to the twin model very short and accurate. And then to have all these distributed twin model instances federated, so they can collaborate with neighbor models. And here we introduce a twin-to-twin interface, as you can see here. Model verification. So in particular, if you make use of machine learning, artificial intelligence models, they may be accurate for a certain time, but they need to be verified if they are still accurate enough. You may operate one AI-based twin model, and in the background train and build a new one which replaces the old one, and it's supposed to be more accurate. So model verification is a very important aspect here. Shared network controller, as you see, it may be shared by multiple users, but also by multiple instances of a network twin, which on the northbound have the control to schedule monitoring policies, then to receive data points, and in the end to enforce changes to the network. So that shared network controller is something that implies a couple of more challenges, which we describe. And then last but not least, NBI, semantic interpreter and solver. So there is an interpreter function which receives the probes from the different users. They have to be interpreted, either it's detailed kind of actions or it's intent-based. So that kind of probes need to be properly interpreted. Next one. All right, so talking a little bit about what Martin and his team did, I think you should be online too for detailed questions, probably with a big cup of coffee in his hand. So the software-defined network twin, so they started to build a twin based on SDN, open source, and they wanted to see about the real complexity behind extracting information from a physical network. How to feed back from the twin back to the physical network. They have two extremes defined, which is a static test system, which is just a snapshot of the real network in the twin. And then you can apply changes and at some point on demand, push back the changes to the physical network, or a live reacting system, which they want to look at, but that's the next step they want to do. So live reacting system is more real-time closed loop synchronization between the real network and the twin network. The overall objective is to find first tangible experiences with that implementation, and to mention it's not conflicting with further extensions, which they do in the next step. So the number of question challenges, or some of them, is of course looking at the interfaces between the different components that we explained before, and which you can also find more detailed in the group's architecture draft. Granularity, which information and at what time is required in terms of resolution. Advanced challenges like conflicting changes to the twin or modeling requests, it's out of scope for that current activity. Next slide is the last one. So that shows the principle of the testbed that has been built by Martin and his team. So it's a static test system which represents snapshots. So you can have a snapshot of the physical network in the network twin, including an SDN controller in the network that you see below. You can work in the twin part and on demand push a button and you enforce these changes in the physical network. So the implementation is based on GoSDN controller in both the physical and the twin network. VNF had been used to retrieve the topology from the SDN controller in the physical network and to copy that topology in the virtual network in the twin. Container lab has been used in a virtual environment. And then actually on the left-hand side in the real network, real switches have been used, and accordingly, models of these switches have been used in the NDT part. Southbound interfaces to the SDN controller. GNMI has been used with OpenConfig Young models for the configuration and retrieval of information, and tests have been performed with real Arista switches in Arista EOS on the virtual part, and own GNMI target implementation has been done to actually apply also other networks which are based on open source Linux, etc., and not on physical switches here. So more of that you can read in this or advanced version of the draft. If there is interest, we continue working on it, and we are interested in your feedback. Thank you.
Other questions? Check the queue on the. So if you have a question, you need to enter in the queue from the tool, please. Sorry, I'm disconnected.
Sure.
So we have
Who's
I'll go.
first?
Arash
Quick
Mead
question.
first.
Actually, maybe two. For the static test system, the snapshot, does it actually contains information about the flows in the network as well? So we
About
can
the-
actually, the snapshot that we
Yes.
take from the static test system, does it contain the flow information from the network so we can actually replay it? Or do you envision that?
It is more states, not on a per flow basis, as
Okay.
far as I learned from Martin.
Right. The second question is about the real time. So when we talk about the real time implementation of the NDT, what type of requirements do you envision that this will put on the interface between the digital world and the real and the physical world? How fast we should actually be able to communicate between the two worlds?
So this work started slowly, and we want to investigate more options like the real-time options later on. Actually, these requirements come from the final user of the NTT, right? So you may be happy with a snapshot-based approach, but real-time really depends on the accuracy and speed and simulating, and at the same time enforcing these changes to the network. So it really depends on the use case and the user behind, in my opinion. But do we have Martin there? Can he also comment? Stimmelig, no?
Yeah.
Martin, still awake?
So I can catch up with you after the meeting as well. I have a couple of questions that you can probably talk and see where we're going.
We
Alright.
can do that offline.
Absolutely, yeah,
anyway.
sure.
Yeah, sure.
Thanks, Marco.
Arisma.
So Carlos Bernardo, CUC3, very interesting piece of work. I have two questions. One, maybe I missed that part, but does this network digital twin support also applying like AI ML to forecast some of the status of the network or the components that you have in the digital twin and react based on that, in addition to reacting based on the actual proving that you do in the physical network elements?
Well, you prove and see the reaction of your probe and or change in the twin, and then you can decide if you enforce it in the physical network. The model or the SDN-based network does not yet imply any model which allows you to predict. So that's one of the next steps.
Okay, and the second question is, do you plan to put available any of the software as open source for others to play with? Or?
Yes, that was recent work. Currently, a paper is being written and to be published. I think a reference to the source code you can find in the draft. Yes.
Okay, thanks.
Paul.
Okay, I'm next in the line.
Oh.
My question is about, I mean, you give an example here, but according to the, let's say, set of challenges that you listed in the first part, I mean, what is your, let's say, your learnings or feedback you can share on this specific NDT, let's say, experiment that you are doing? What will be, let's say, key aspect of the challenge? You say we have addressed this, or we were really having struggled with this aspect, real-time, synchronization, parallelism. What would be your experience and learning?
So the challenges and the thoughts, it's based on brainstorming and experience. So this is a real first hands-on experience. Maybe there is more advanced kind of experiments, which would be a pleasure to review and discuss about, right? So this is just hands-on experience. And one of the challenges is really to have different levels of accuracy you need from the systems. Referring to Arisma's question about a flow-based twins and accuracy. So you have IPFix, you have various tools to export flow information, but the amount of data you have to process is enormous. And if you need to do that not for a single node, but for many nodes, aggregating that information is a problem. Bringing that information from a very far away endpoint and node in the network to the aggregation point that builds the twin, you have a delay, right? And how that delay has impact on the accuracy of the model, that's something you need to consider. So that's something like lessons learned, but as said, we are more progressed with the challenges based on our analysis than with the hands-on experience of the SDN twin.
Paul,
Okay.
please.
Okay, this is Paul from SKKU. So, very good presentation. So, Marco, I have two questions. The first question is, so operator point of view, it gives us some kind of some goal or some intent, like some end-to-end, some delay or some throughput, something like that. So that kind of high-level requirement should be translated into some low-level, some configuration having some parameters, right? So how do you some impose that kind of configuration, some generation given certain goal or intent? That is my first question.
So as clarified before, in general, a network twin should support both intent, but also detailed kind of configurations from users regarding probe and enforcement. Your question, is it related to the theoretical analysis of challenges or regarding this prototype?
Right. So a kind of prototype.
For the prototype, we don't use intent. We use the regular SDN controller's northbound interface that a user can use to apply changes in the twin, and if wanted, then also enforce it in the physical network. So it's not intent based, but experienced user.
Okay, good. So second question is about the accuracy about network twin model. So the accuracy is very important to give good feedback to a physical network. So my question is how to build the model for digital twin. And secondly, so if there is some discrepancy between the digital twin model and real some behavioral network, so how can update or enhance your twin digital twin model? Yeah, that is my second question.
So from practical experience point of view, I cannot give you a good answer, but from research perspective, and I think that that's well known, right? It really depends on what users expect from the network twin, and that has impact on how you model the network, right? So maybe you don't need to break your model down to physical node or even a port basis. If you have a switch, right? Do you want to consider all the 32 ports of the switch in your model, or you just model that node based on the switching blade capacity, right? And you can even go more abstract here. So which abstraction level you consider really depends on what you want to model with your probes and then get a result about.
Okay, I see. Okay, thank you.
Yeah, sure, you're welcome. Thanks for all your comments and questions. Is there more?
Yeah, there are two more questions. One is from Cheng. Online, yeah.
Hi, Chair, and hi, Marco. Question here. First one is that what will be the resource consumption to support large scale switches or firewalls or routers in physical network? Because you are using containers to build the virtual twin, right? The second question is that how to build virtual twins for physical entities in case you cannot get the proprietary or correct OS for container. For example, some traditional or some legacy switches are with no open source resource OS or some OS is not available. So as guess here, thank you.
So if I understand the question right, so if you want to have an accurate model of your physical network, in this case, in the network twin, and in this case, we have accurate models, and your first question was about the amount of resources. And for that small network, we didn't have a scalability problem. So we have these resources for these various nodes that we model. Of course, if you do that for a production network, which is huge, more resources need to be considered. So maybe here a kind of decentralized approach for building a couple of twins which federate with each other is a better approach. Or you abstract your physical network and don't have accurate models of each node that you deploy in the real network. That's another approach.
Thank you.
You're welcome.
Marco, just to be sure I understand the kind of workflow here in this static test case. So your twin initially reflects the state of the network, traffic, et cetera, as it is. And then you have test applications where presumably you're trying different states, et cetera, to try to optimize something. And then having found something you like, you may choose to push that state back onto the real network. Is that correct?
Yes, that's correct.
Okay, and then in an automated system, you would have to sort of put that in a closed loop. I mean, it would have to know the objectives it's trying to optimize, use the digital twin as a sandbox, and sort of automate the process of finding a new or optimized solution, and then that's what goes back onto the network.
Yeah, in the second option, you have way more interactions in terms of a closed loop by monitoring, reflecting in the twin, and pushing back.
Yeah. Good, thank you.
You're welcome.
Ali, you're next.
Sure. Thank you for a great presentation. But as someone who has been working in this field for years, one of the biggest challenges that I have faced is the scale. If you really want to have a twin of your network, it's huge. Either in simulation I have tried, in emulation I have tried. After a while, you are consuming so much of resources and energy that you can't scale it anymore. So has there been any thoughts around that? Has there been a way that, for example, you think that we can go into data-driven approach, AI-driven approach without loss of performance that we want to get out of twin?
But that's more a general question, not on the SDN prototype, right?
Well, it is actually related to SDN as well, because you can't scale this. I don't think you can scale this.
Yeah, well, that's the point. So we started small, so we scale. But if we have more nodes, probably we run into problems. Yes, it's the same question as before, similar as before, right?
Okay, but maybe just one comment to this point on scalability, because I think scalability can, depending on the dimension you look into, can be addressed or can be more challenging. Because if the scale, for instance, is, let's say, the number of instances you can represent, maybe some limits where we can scale, but maybe you have other constraints to scaling. It could be more from, let's say, as Michael was mentioning about the time responses. Because if you want to reach a too big network and it starts to have too much delay, then the scale is not the issue, but the issue is coming from the breadth of the network that you are trying to address from a time perspective. So I think from the draft challenge point of view, I think scalability is labeled as it, but maybe when you look into scalability, it may not be triggered by the same aspect of what you are trying to do.
Yes.
The limiting factor may be scalability, but it may be generated from different, let's say, life cycle phase or constraint of the system that you are trying to model.
It's various aspects, the resources included, but also if you have a large network, I mean, bringing a huge amount of data points over the network to a single central aggregation point may consume even more resources, but also may have a negative impact on the accuracy of the model because they are not time synchronous. You may apply PDP to all these nodes to have synchronized clocks and use timestamps with your reports, but well, you have to really assess also the costs that you invest in getting an accurate model, or if another approach from design perspective is a better one, which means a more decentralized approach that federates.
But Ali, please share, I mean, offline or on the mailing list or feedback to the draft about your experience on scalability issues. And of course, since this is research, exploring also what could be path to address those scalability challenges. That would be much welcome. Thank you.
Sure, thank you.
Rashmit, you still wants to have something to bring?
Just a quick comment on actually scalability. So the scalability actually goes hand to hand with what you want to actually the digital twin do. So the more precise the digital twin actually is following a network device, for example, the more detail you have to capture, and that basically puts a requirement on in terms of scalability. So the size of the network, how far you want to actually be able to represent the device, to what details. These are all come to play a role in terms of your scalability. I guess one part of the research could focus on like what levels of digital twin for the network can provide what type of services to the user. Right, that could be a good probably research topic to actually concentrate on. If I want to draw a couple of, because unlike the physical world, like which I'm trying to actually create a digital twin of this room, the network device requires a lot of effort. And by the time to actually we get to represent the digital twin of a device like a router, then why do I need the physical router anyways? Because I have a software version that actually is behaving just like that. So we cannot really expect the device in the digital world to mimic exactly what the physical device is doing, because otherwise we are abolishing we are diminishing the need for the physical router or switch or whatever. So the software switch, they're already there. The question is that how we can use the existing ones without going to the extent of completely resembling the physical node and get the biggest bang for the buck.
Yeah, well, physics really limit what you can do in the twin, and I fully agree with what you said. But I see there is a lot of interest, also good ideas and very good questions, which we should further elaborate, right? So let's make use of the NMRG Explorer and platform to do that. Thank you very much.
Yeah, thank you. Thank you everyone for the nice comments and questions. And as concluded, I think we need to reiterate exchange on the mailing list with the authors to reiterate on this work and capture aware of the different, let's say, challenges and how we could address them. That will be very good progress for this work. Thank you. We need to move on to the next one, Dan, please.
Oh, it doesn't work. Okay. Great. So I'm going to orchestrate. So the second digital twin topic this afternoon, essentially this is the concepts and reference architecture document. My name is Daniel King, Lancaster University. Next slide, please. So some of you may remember that there have been several threads on the mailing list regarding questions of the document, mostly around terminology, concepts, some of the functional components. The previous version of the document was closely aligned with using NDTs in the context of an SDN controller. There were also some documents that weren't being referenced externally, external documents. These are ETSI, for instance, ZSM work that had NDT requirements. And what we ended up doing was having, along with the several email discussions, some interim sessions specifically talking about digital twins and regards to this piece of work itself. Now, these were public discussions initially, and those were open. The meeting information was provided on the list, and we then sort of took some of that discussion offline. So, next slide, please. Oh, cool. Okay, we have the technology. Now, most of these issues were logged in the GitHub, so you can see how they were resolved specifically, and they refer to sort of 4 or 5 sections of the document itself, as well as just clarifications of some of the concepts and cleaning up of some of the figures. Right now, I believe we have no issues, or certainly few issues remaining in the document, but you can certainly check to see what's currently outstanding. So what were the, I'm the app may need to be in the foreground. Nope. Try again. Yeah, okay. So where were the changes made? Specifically, we have introduced a logic element in section 4, which sits above some of the functional components of the network digital twin. We've expanded and clarified the key functional components of the network digital twin. This is done in section 7, and I'll go through these in a little more detail shortly. We also provided, I guess, a framework more than an architecture. So how you would take those functional components of the network digital twin and apply them, sort of instantiate them for a particular use case. And actually, this is sort of an intent-based example. But listening to the previous conversations around some of the outstanding questions, one of which was intent and how you map sort of declarative requirements or objectives to imperative, i.e. intent to policy, those are sort of out of scope. But maybe instead of just stating that these are out of scope, maybe we need to start thinking about, and it sounds like the previous document would be a good sort of format to catch them, but unanswered questions regarding digital twin or NDT, because certainly intent mapping and compilation, sort of how you compile intents into imperative statements or objectives, scalability, privacy, these are all sort of open research issues. Another key area that needed further discussion, really to kind of round out the document itself, was security. And there was previously sort of a general statement about security in regards to digital twins, and maybe this sort of covers some privacy aspects as well as and confidentiality. But clearly, network digital twins represent a significant security concern. There are certain actors, certainly threat vectors, that could be used to attack or gain sort of unauthorized access or information about the network. So what we've tried to do with the latest version of the document is just kind of highlight some of these considerations. Now, the document doesn't specifically state how to address them or mitigate or negate them entirely, but simply you need to be aware that these are issues. And there will be, certainly within the IETF, certain techniques that could be applied that would help address those. So Chris, did you want to ask the question now or at the end? Okay. And then finally, as we conducted a detailed review of the document, what we've tried to do, and I think this is an iterative process, is just clean up the text, try to make it a little more readable. It's a relatively long document. As we prepare this and stabilize it and hopefully finish it and publish it, we'd like to try to make it as clean and as easy to read as possible. Great. So specifically, these are the changes, and you can see them in the latest diff. But we kind of moved out some of the logic function from outside of the digital twin to essentially feed into the digital twin. So you would be able to kind of ask a series of questions depending on the organization, the type of analysis that you're looking to perform using the network digital twin. So it may be security, it may be planning, it may be some kind of optimization, it may be re-optimizing the network after some catastrophic failure. So all of these are sort of certain types of analysis or function that you want to use via the digital twin. We also provided some text along how these logic functions are actually used. We have rewritten section 7, or at least expanded section 7 to talk about how these functions can be applied. And then this is the sort of framework where we take some of those architectural components and use them in a specific instance, the realization, the instantiation. And now we can see here the sort of closed loop of a network digital twin, and you could assume that there are sort of interior or inner loops, as well as maybe an outer loop in a sort of recursive deployment where you have multiple instances of network digital twin, which would actually be one way of addressing the scalability issues of building network digital twins. We've already sort of discussed previously that there may be some computational limitation for the size of digital twin that you would have to build depending on the size of the physical network. And what we don't want to do is essentially use the same computational or compute resource to model a network that is actually maybe in the context of NFV. The virtual network, the VNFs that are being instantiated to provide network connectivity and certain types of services obviously require a certain amount of memory and CPU and network. You wouldn't want to replicate that when you build a digital twin in order to set up or deploy services across it. So what we've tried to do here is show how you would realize a network digital twin and what the sort of closed and the inner and the outer loops and the relationships between the data and the functional components. I mentioned the security section, so this is the high level sort of, I guess, the section and then the subsection, the kind of data that you would need to consider in terms of privacy and confidentiality, the interfaces that are potentially at risk. So think of these really as threat vectors. There is a limited amount of discussion on how these could be addressed, but certainly not enough that you would use them for sort of operational purposes. Those will be based on implementations, the open source that's being used, or some proprietary mechanism. So finally, we've almost, I believe, addressed all of the outstanding issues that were raised on the mailing list and discussed on the various interim calls, as well as the issues that were documented in the GitHub. We now have sort of a decision point where we can close the document through another significant review by the authors, and we would also ask the research group to take a look at the recent changes and also read the document. If you haven't sort of done a full pass of the document for a number of months, now is the time to review the document before we move forward. There is also an open question about the example that we have, the framework, so essentially the implementation, realization discussion. Would this benefit the document if we left it in as it currently is, or should we look to move that example out into a new document? If we want to continue to document this particular example and the framework, it's only going to delay the existing document. So we kind of, I think our preference is to finalize and finish this document as soon as possible now. I've been looking at several other documents that reference this document. Within the IETF, there's at least 5 or 6 documents. Outside of the IETF, when you look at sort of several research projects, as well as numerous sort of academic papers that reference this particular document, I think really we want to kind of finish it and move on. And sort of the unanswered questions that we've discussed previously, those would be better addressed in other documents or new documents as well. Okay, any questions?
Hey, thanks, Dan. Since I was one of the motor forces with some people in sort of spurring some of the reflections that gave rise to this change. I do want to put on the record of the meeting, and while the chairs are here to hear it, I think that big strides have been made. I agree it's not quite there. Figure 2, I think, still has to go, and Section 4 a little bit, and general editing, but it's definitely in a state where I personally feel, and I think those who had similar concerns for the most part, though I don't want to speak for them, I think certainly I would be comfortable with and pleased to support this moving forward in the next period to publication. I definitely agree that I think the way it is, it's not any kind of rigorous architecture document. It's much more on a conceptual level, but it has all of the elements necessary to kind of understand what the thing is, how it's used, and sort of illustration of that in a way that the reader can extrapolate. So I agree. I would leave it the way it is, lock it down, and move forward. And very important that we do that, I think, so it is serving as an industry reference. So you know, we should finish it up. And I just want to thank the authors for their openness to reworking some of these issues, and yeah, thanks.
Great.
Rashmit from Norway. Two questions. The first one is that about the interfaces between the physical and the digital world. So I'm assuming that you're going to at some point define those control channels and the data collection channels. My question is that are we planning to actually piggyback on the existing protocols or not? Is there any mention of this thing in the document, or if not, probably that might worth mentioning that in the document?
Yeah. So thanks, Arashnet. So this is exactly what we want to avoid, and it's a really good sort of observation. The kind of use case that I've been looking at for digital twin is sort of optical networking, multi-layered optical networking. And there are several interfaces that we could use in order to kind of extract information from the network. Some are sort of control plane specific, other are management plane specific. And actually, the more I investigate how to kind of generate the digital twin from a real network, the more options I find, and the more kind of scaling and computational requirements or concerns I have. So I'm kind of minded to kind of leave things as they are and just make some assumptions and say that some method would be required, whether it's netconf-yang or REST, some kind of RESTful API, or a passive instance of OSPF or ISIS, or something else entirely, and save that for a new document that says, how do I now use the NDT for a transport domain, in an optical transport domain?
So all I'm trying to say is that probably some little statement in the document might be helpful actually to explain this and say, okay, this is out of the scope of this document, and we can actually just move forward to later on document.
Thanks, Arashnet.
The other question is about security. Do you see, so given that the existing monitoring and configuration systems basically somehow have to deal with some of these security issues that exist out there, do we see additional risk and it might be some comparisons that we might actually make between these two aspects and see why using the digital twin requires an extra cautious in terms of security perspective?
Yeah, and that's another really good observation. Look, as an occasional IETF engineer, when I write a protocol specification or extend an existing protocol or write a Yang model, I consider the security implications for that specific layer or that specific interface. Now, what we have here is the holistic approach. And I think what we need to do is really consider the security implications of a system rather than a single interface or a model or even a single layer. And I think actually the IETF doesn't generally do that sort of work. What we have particular areas and working groups, and they're very narrow. And now we kind of need to actually look and say, well, what happens if the system is compromised? What kind of access will people have access to, and how do we harden? And what are the threat vectors? Now you have organizations like the ONF that had a specific security working group, and sort of Sandra would publish routinely sort of documents that say, what is the best practice, or that you'd have a particular piece of open source that would do intrusion detection. Maybe this is something we need to think about in the context of digital twin.
All right. Thanks, Anne.
Thank you. So we are taking the comments from the people in the queue, but we have to be quick, please, because we still have 2 presentations and we are a bit short. Thank you.
Okay. So let me ask you two quick questions. The first one is clarification question. So Daniel, so can you explain the difference between inner loop and closed loop? So yeah, what is differences between 2 loops?
So the inner loop is essentially taking information from the network and then generating a model of whatever currently exists or forwarding technology, and then applying the specific objective function that says sort of test failure scenario or set up a service. And then as the network changes over time, you may get a different response or a different answer depending on your intent. And then sort of an outer loop may be an external factor that's not being modeled by some sort of direct information from the network. So this could be a multi-domain situation, or some external environmental factor that may also be considered when performing some kind of optimization or planning function.
I see. Okay. So another one is a comment. So I looked through the text in this section. So I think very nice picture, but it will be better to add some references, such as intentionalization or some closed loop control, something like that. Some other standardization body like TM Forum or Camera and also GSMA, they are working intent, something like that. So we can add their activity. Also we can report to academia the paper, so how to realize this system. So to put more references, it will be enrich this section.
Yeah, intent is, as a concept, has been around for decades already, and there are several languages that could be used, like sort of group-based policy or role-based access control or network intent composition. So and some newer proposals as well, so we can include some references there. The compilation, so the engine that would translate declarative to imperative, if anyone has a reference I could use for that as a particular engine, even if it's an open source project, that would be really good. We can include that as well.
Okay, I see. Thank you.
All right, thanks, Daniel, for the summary of this update. Very quick. So one comment, one question for curiosity. So the comment is, I think it's good to go beyond the framework or the architecture that's presented in a draft and bring a kind of more concrete example for a particular use case. So I don't think this is a reason to strip it off from the architecture draft. Second, it's a question. So do you have anything that substantiates this little bit more complex system that you present in the example? Is it something that you just derived on paper, or is there a kind of prototype? Or
yeah, it's
like
stylized. So there's it's conceptual. So there's no, as far as I'm aware, there's no sort of published or transactional results that show this in operation somewhere. So it's just an example.
But it's confident, so it works.
Yeah.
Okay. Right. Thanks.
Just a couple of comments, brief as well. I think that we should not, or we should avoid trying to reinvent the wheel as much as possible. So I both analyze when talking about the protocols, etc. I would try to stick with what we have. Probably profiling or making some additions, etc. when it comes to security, to trustworthiness, to timeliness and things like that, but not to avoid this. And this is, and regarding this, or related to this is, and this is something that probably we should have discussed as, among the authors, but I'm quite in favor of splitting the documents, because, I mean, the conceptual framework is there and it's something that can be, I think that the whole group agrees on that and we can move on. For the other parts, for the parts of more detail about the architecture, the possible protocols and choices, probably we should spend a little bit more time, and including bringing some examples, choices, etc. But so far, publishing this as I mean, the conceptual core of the idea, publishing it, going for publishing it will be useful.
Thanks, Diego.
Hi, very quick, Carlos Bernardo, UC3. Just to put in the record that I volunteer for the review of either this version or a future version. Just trigger me offline and I will do it.
Fantastic. Thanks, Carlos. That's very much appreciated. Thank you, Jess.
Thanks a lot. So maybe just a bit view from the chairs. I mean, I appreciate a lot the work that has been done on this, let's say, document, and especially all the activities that authors and participants have put into that. So that's very good progress to see, because it's not easy. It's a complex document. We see also that there is a bit of an underlying question about the future of this document, one document, multiple document, to split or not to split, etc. So what we will do is to check the research group consensus. So it's not something that we have to do, but I think here it's a good thing to try to collect a broad set of opinions about what should be the fate of this document, according to, let's say, a few questions that we are listing with Jerome. And then out of that, to try to communicate to the group and see actual thing that can be done. Of course, try to keep in mind the timeline. So of course, try to have something ready in advance of the next IETF so that we can iterate, split or not, and then see from a more documentation point of view. But let's say that there is an action on us to move forward with this call for research group consensus and see what we can do for that. Keeping in mind the research also, let's say, outcome we expect to get from that. But since this document is also starting to be reference, I think it's also good that we can have something stable for others to progress, and also the group to progress on other aspects. But thanks a lot. I appreciate it for the work so far. Thank you. So next one, I think, is Ignacio. Yeah. So we are, let's say, very short. I mean, just 3 minutes out of delay, but I think, so you have time for your presentation, but if you want to save for questions, then up to you.
Okay.
So, hi everyone, my name is Nacho from Telefonica. So today I want to take advantage to introduce this new draft called Knowledge Graphs for YAM-based network management. So, there we go. First, why this draft? In this work, what we want to tackle is a problem that is happening across all industries, which is that since the big data era, we have seen a proliferation of heterogeneous data sources, tons of them scattered and managed as silos of data. This is a big issue, now especially with the advent of AI and ML, because we see that these applications should make use of this data. They are not benefiting of it, and we have to facilitate them let's say, discovery, understanding, access on, and the combination of all of this data to unlock new use cases, especially in AI. And the network industry is no less. In particular, the network telemetry framework, RFC 9232, very well describes this issue, outlining all this variety of protocols like IPFix, SNMP, netconf and so on, formats as well, even logs, traces, XML, CBOR, levels as well, management, control, forwarding levels. So we see all this variety, and looking just at the YAM ecosystem, we see that this is already a big challenge for the industry. First, we see that there's many times we have seen this a tsunami of YAM data models coming from the standard organizations, proprietaries, also from open source communities, consortia like OpenConfig or OpenDaylight. Also, we see that there are different levels of abstraction at the device level, at the network, also at the service level. Similarly, protocols as I said, netconf, resconf, node push, UNMI, as well as formats, XML, JSON, protobuf, CBOR. So we see that all this heterogeneity must be tackled, no? So what do we propose to especially combine this data and make sense of it? We propose to apply this new paradigm of knowledge graphs, which it's a promising candidate to enable the integration of all these heterogeneous data silos. And we can do this in knowledge graphs by building a semantic layer based on formal knowledge representation. This is commonly known as ontologies, taxonomies, and so on. So what this draft provides is guidelines and recommendations for building knowledge graphs, in particular from young data. So these guidelines can be, let's say, split into three main pillars. One of them is the available graph standards. Here is the the semantic web standard from W3C with RFD, OWL, and so on. And now label property graphs have appeared as well with Neo4j as a popular commercial solution, also NGSILD from Etsy. The second pillar is the development of ontologies, where here we are exploring methodologies for developing these ontologies. But as well, we are also exploring the automation of the extraction of knowledge. And the third pillar is the construction of the knowledge graph itself. Here we have approaches like data mapping based on declarative languages like RML, which will allow us to map raw data that we collect from our network and map it to ontologies, meaning to their concepts. And this work is the result of an ongoing research that we call Candle. Here I put the link to one of our latest papers. To give you an idea, what we did in this paper is we, by using a knowledge graph, we were able to combine data from the network topology model, also from IETF interfaces and OpenConfig interfaces. Okay, so some potential applications of knowledge graphs. The list is longer. You can see it in the draft, but here I wanted to highlight a few. First is service assurance. This is the first application that always comes to mind. Because if you take a look at Sign, this is a graph with dependencies between services and symptoms. By integrating this data, the same data in a knowledge graph, we would be able to combine this data with other data, like, for example, device data or network topology data. Similarly, network digital twins. We have seen a couple of presentations before, and that's one of the reasons for introducing the knowledge graphs today, because network digital twins, the knowledge graph paradigm is well aligned with the architecture proposed in the network digital twin architecture. In fact, it's mentioned a couple of times in the draft. And also, it aligns with the work that it's been done in the digital map draft, where in this draft, the authors are identifying core concepts and the mappings between different GAN models. And this is precisely what we want to achieve in the knowledge graph. And similarly, the data manifest. This is a great example of managing metadata in a knowledge graph and providing contextualized understanding of your data. No? Some challenges to improve the adoption of knowledge graphs in network management. Well, first is ontology development. I would say this would be the greatest challenge, because we need people with skills on semantic modeling. The process is mostly manual, so that's why we are also exploring ways to automate the extraction of knowledge. And also exploring in this sense if we should go for standard methodologies to help people develop these methodologies, these ontologies for their use cases, or work on standard data models. Second, scalability. This is also a very important challenge because the size of the network is huge, getting more complex. So for this, knowledge graphs could be built on distributed and federated architectures. Also, they must handle high volumes of data. And also, another important issue is real-time use cases. This could limit the adoption of knowledge graphs. So in this sense, the construction of a knowledge graph should have very low latency to support these use cases. And another kind of challenge is network configuration. Because typically, network monitoring is, say, the first use case for integrating data in a knowledge graph. But we're also exploring the possibility of having configuration data in the knowledge graph as well, to use this to configure network and enable a closed loop. Some open issues, well, if we should keep the focus on YANG, as I said, this is the main target of this document, or if we should broaden the scope of this graph and include other data sources like IPFix or SNMP, and in this sense align it with the telemetry framework, RFC. Another issue is we need a home for ontologies. As I said, ontologies is the core of a knowledge graph, and this must be developed and shared somewhere, no? So I don't know if this could be the IETF, go for an open source community approach, more agile, see more people, external people involved. And the last question is if this draft would fit better in NMRG, because as you know, this has been originally proposed in the MMOP working group. So that's why I wanted to throw this question today, because on the one hand, I see that the concept that an architecture maybe could fit in NMRG and then have more practical use cases in MMOP. Let's see. And the last slide, the next steps. So of course, the goal is to keep collecting feedback from the working group and the IETF, and looking for interested contributors. I know all this seems very abstract, so to better grasp the idea, we started working on a prototype to create a knowledge graph based on the augmented YANG library extension. In particular, this will require the development of an ontology for the YANG library, and also the construction of the knowledge graph from a netconf source. And the target is to demonstrate this by the next hackathon in Dublin. And also we are exploring integration with other works within the IETF, like the YANG Kafka architecture, because we see there are some pieces that could be leveraged as well to construct the knowledge graph. So that was it. Thank you. Any questions?
Thanks a lot, Nacho. Exactly on time. Questions?
Yes, I have one. Can you go back to the slide where you present the challenges, I think 2 slides before?
Mm-hmm. This one.
Yeah, maybe one quick question regarding scalability. Are you referring to scalability to build the graph or to use the graph, or both? Because I think if you build the graph is to be more efficient to access and retrieve data, should be more scalable, right?
Yes, so here the idea is that to address scalability, one of the options is that in a distributed or federated architecture, you could have fragments of your whole knowledge graph spread, let's say. So for example, you could have a fragment of your knowledge graph at the edge and the other at the cloud. And with this architecture, you could have a unified view of what you have in both. No? That could be an option to address scalability.
Okay. Thank you.
Thank you.
Next presenter, please, Yongin.
Okay. Good afternoon, ladies and gentlemen. My name is Yonggun Hong. I'll present a consideration of network system for AI services. So this is 06 version. So in this draft, we have four authors. It's me and Ju Sang-yoon and Dong University and Sung Hong and Yoon Sun-yoon and Etri. Okay, this is the history and status. So March 2022, we submit 00 version, and July 2022, we present it the first revision, and this time is the sixth revision. So, and this is the fifth presentation. So this is the update since last meeting. So in this time, we rename of the title. So the previous title is Consideration of Deploying AI Services in our Distributed Methods. But now we rename the title Consideration of Network System for AI Services. And the second update is we update the context in clause 4.3, consideration for the characteristic of the communication method. And we rename of the D10 to follow the recent change network distribution entity, and we make some change of the authors. Okay, this is the motivation. So in the NMRG chapter, there are 3 items for AI in NM. So the first one is investigate, organize, and document the major research challenges in AI for network management. So I guess our research challenge document will cover the first item. But second and the third item, organize and animate a series of practical network management AI challenges competition. I think we don't have any relevant document. So in the IETF 107 meeting, we have some consensus. We have some agreement for the NMR's AI topics. The first one is challenges of coupling AI and embedding. We need to focus on new challenges, for example, DTN, and some possible work item, for example, distributed AI and deployment implementation point of view. So our goal of this draft is to share experience and implementation knowledge to result to find optimal network system for AI services. In this draft, we don't talk about AI technology because it is not scope. We want to find what is the point of network system to provide the optimal AI services. So to do this, we want to find what is important information to provide optimal AI services and find how to deliver this information between related devices. That is the network consideration. And finally, we want to find how to manage this information because we are in NMRG. So we want to find a common component to provide optimal AI services. For example, common information that is some related to MIB or young cases. And we also want to find common system to provide AI services. Also, we want to find common network architecture to provide AI services and a common protocol to exchange information for AI services. Also, we want to find or make some connections, some useful use cases. The first one is the self-driving cars, and the other is the NDT case. Okay, so in the 06 version, the table of contents are like this. So the main clause is clause 3, clause 4, and clause 5. So in the clause 3, we show some network computation structure to provide AI services. So, nowadays, to provide AI services, we can utilize network or the multiple devices because AI service can be separated training and inference. So to provide AI services, so if we focus on AI inference services, we can utilize network point of view. For example, people to show and local machine and cloud server or edge device, or we can utilize AI services on vertical or horizontal hierarchicals. So in the network side utilization, there are two related to AI technology. For example, federated learning and transfer learning. So federated learning is a machine learning technique that trains an AI model across the multiple decentralized servers. So it enables multiple network nodes to build a common machine learning models. So in the case of transfer learning, it is a machine learning technique that focuses on storing information grained while solving one problem and applying it to a different but related problem. So by using transfer learning, we can utilize a network computation to transfer common information and knowledge between different network nodes. Oops. No. I try. It's now working. Okay, next slide, please. Okay, so in this draft, we describe 3 points of consideration. The first one is the functional characteristic of the hardware, because in a network point of view, we can utilize very different network node, for example, cloud server and edge device and local machine. So, in the cloud server, it provide high performance, but it is very high cost. But if we utilize edge device, it provide medium performance and medium cost. And we utilize local machine, it provides local performance, but it is very cheap. So we can consider and we can decide which hardware that we use. Yeah, next slide, please. And we also must consider the characteristic of the AI model, because each network node provides different capabilities. For example, if we utilize AI service in a cloud server, we can run heavy AI model and we can get high accuracy, big size, but we get long inference time. But if we run AI service on local machine, we utilize light AI model, lightweight, and we get low accuracy and small size data, but we can get short inference time. Also, if we implementing the inference AI inference serving framework, we utilize two kinds of the method. One is the traditional web server, for example, PES-A5, Flask, Django, or we can utilize specialized serving frame, that is, for example, TensorFlow serving or etc. Next, please. And the last final consideration of the characteristic of communication methods, we utilize AI inference service two cases. One is the traditional REST method and a specified communication method, for example, gRPC. Also, we consider AI inference data, for example, real-time or batch or secure or non-secure. Okay, next page, please. So in this draft, we show two cases of deploying AI services. So one is the self-driving car, that is autonomous driving, and the other two is the relationship with the entity case. Next page, please. Yeah. So this is the feedback from the IETF 118 meeting. So in this time, the Laurent said that there is a quite stable and mature work in this draft with the extension to an application use cases. So we can run a less call for adoption. Next page, please. So this time I'm asking for RG adoption to NMRG. Next page, please. So that's all. Thank you.
Thank you, Jürgen. Do we have questions? Okay, so thanks. Oh. Yeah. Yeah.
Yeah, thank you for the presentation. My name is Amr. I work for Huawei Canada. And I just have a question from networking perspective. In terms of training AI models versus the inferencing of AI models. So do you see a dramatic change like, in terms of the network requirements to handle both like training versus inferencing?
Yeah.
Or can we simply use the same network for both?
So in this draft, we are targeting on the inference, not a training. But if we think about the training point of view, for example, federated learning or transfer learning cases, there are some challenges to do. But actually, in this draft, we do not cover that challenges. So it is our homework. So if possible, we want to handle the kind of issue. But right now, I'm sorry to include the kind of the context. So if you have some ideas or some context, then I hope your contribution to this draft. Thank you.
Thanks for the question. I think you can come to Jürgen, but also have a look into the challenges draft. I think there should be something tackling training inference about it. But it's a good point to investigate because, I mean, the context and the requirements are quite different for training or inference in terms of compute, movement of data. So thanks. So yes, we will run a research group call for adoption. Yeah. But I noted some remark. It will be part of the call, but I share it now. So first, we have to be careful on the scope of the document, not to make it too big. Yeah. I'm just making, see, eventually, if it gets into an RFC, what will be the type of research outcome we want to get from the draft. So if we start to bring in use cases or expand the draft to too large scope, this may be challenging when we start to go for publication because this could be more challenging questions. So if we can have a good focus on the scope, that's easier also for the long-term fate of the document.
Yes, I agree.
That's more cosmetic, I will say, but you refer actually to the challenges draft. Yeah. It will be good also if we can make the link. You see, for instance, what are the challenges from the general challenges draft that the subset that you tackle, and that you say your investigation is targeting on this challenge and these are. So that could be a good way to link the two documents.
Okay.
Yeah, and that's mostly that. But again, it will be part of the research group call for adoption.
Thank you.
Thank you very much. Thank you. And that's a success. We are just on time, which for us is very exceptional. So thanks everyone for the very good presentation today. I really enjoyed also the comment on the mic. We have another session later this week, Thursday. We will address more, other topics on intent-based networking more specifically, but also the research agenda. So if you have any thoughts, proposal, ideas, please also offline, or you can come to us. It will be very welcome to have expression of the interest of the group for the research agenda definition. But thanks to everyone. Have a good evening. Bye.
Thank you. Bye-bye.